So what we're going to be doing today is we're going to continue on that elimination method, or what we call the add and subtraction method. And we're going to continue on it so that we can use it for any linear system. Because before in class, I said sometimes we would be able to use the elimination method and other times we wouldn't be able to use it. But now I'm going to teach you how we can use multiplication along with the addition and subtraction, and you'll be able to solve it using that elimination method. So the objective after the video, you should be able to solve a linear system by elimination, adding and subtraction, when you have to multiply first. So in a situation where you have to multiply an equation first, and I'm going to explain how we do that. So before, we'd have a situation like this. We'd have 2x plus 3y equals 11, and negative 2x plus 5y equals 13. And our first step was to make sure that our variables are lined up. We have 2x and negative 2x, 3y, 5y, 11, 13. They were all lined up. And our next step then was to either add and subtract. And because we have the 2 with the negative 2, they were the same, but one was positive and one was negative. We then knew we could add the two together, and it would cancel out the x. So if we did that, those would cancel out. We'd have 3y plus 5y is 8y equals 11 plus 13 is 24. Divide by 8. Y equals 3. So we'd get our y, then we'd substitute in the variable into one of the equations. So I'm going to plug in y just into the top equation. I have 2x plus 3 times 3 equals 11. Gives me 2x plus 9 equals 11. Subtract 9. We'd get 2x equals 2, or x equals 1, and we would have solved our linear system. And that's because we had a 2 and a negative 2. But now, what we're going to be talking about is what if none of our numbers line up? What if there's no number? So we don't have a 2 and a 2. 2 and 3, well, we can add or subtract. They won't cancel out. 5 and a 10, we could add or subtract. They won't cancel out. So now this would have been one before that I would say, well, you can't use the add and subtraction method the way we knew it. But now I'm going to teach you how to use the multiplication part first. So what we're going to do is we're going to see if any of these two numbers, if we can multiply one of them to make them the same. So is there anything we can multiply 2 by to make it 3? Well, no whole numbers, so that doesn't work. Is there anything we can multiply 3 by to make it 2? No. Is there anything we can multiply 5 by to get 10? If you think about that, well, we know 5 times 2 is 10. So what we can do to allow us to use the multiplication method is we can multiply this entire equation by 2. And if we do that, 2 times 2 is 4x. 2 times 5 is 10y. There's an addition sign between them. Equals 2 times 3 is 6. And then we aren't going to multiply anything by the bottom one, and we'll get 3x plus 10y equals negative 3. Now do we have numbers that we can add and subtract with? Well, we have our y's. They both have 10s. They're both positive. So we talked about in class, if one was positive and one was negative, we would add. And if they were both positive, then we would subtract. So we can subtract these two now. 4x minus 3x is 1x. 10x minus 10x will cancel out. Equals 6 minus -3, subtracting a negative, so we can keep change. 6 minus -3, or 6 plus 3, would be 9. So we know x equals 9. So we've solved for this. Now what we can do, substitute it back into our equation, and we can solve it for our y. So I'm just going to plug it into the bottom equation. 3 times 9 plus 10y equals -3. 3 times 9 is 27, plus 10y equals -3. Subtract 27 to both sides. We get 10y equals -30. Divide by 10, y equals -3. So my solution then to this linear system would be x equals 9 and y equals -3. That's our solution for that. So the difference between these two equations, or what we did before and what we're doing now, is we have to decide what do we need to multiply an entire equation by to make something able to cancel out. And that's the big difference between this elimination method and elimination method with multiplication first.